Welcome to lesson 3 of 3 in our series on GCSE ratio. Now today we're going to be working with a grade 5 standard question, 2 questions in fact. So if you're keen to achieve a grade 5 or to secure a grade 4, this will be particularly important for you. Before we go to those problems, we're going to have a look at some key skills which are pretty fundamental. So have a look over here at something I prepared earlier. Firstly, to think of ratio in terms of fractions. We've talked a lot about the bar and how to turn a ratio into a fraction. So here, Jenny, in her ratio, has got 3 parts out of 8. So the fraction Jenny has is 3/8. And we see Julie has got 1, 2, 3, 4, 5 parts out of the 8. So the fraction Julie has is 5/8. Good. That's thinking of ratio as a fraction. The other key thing to be good at is finding fractions of fractions and percentages of fractions. Now the big word there is of. Of means multiply. Think of this. 2 lots of 5, 10. 2 times 5, 10. So of means multiply. Now let's look at that with some fractions. Let's do 3/4 of 2/5. Remembering of means multiply, we change this to 3/4 times 2/5. Now multiplying fractions is straightforward so long as you can remember the rule. You basically multiply across the top. 3 times 2 is 6. Multiply across the bottom. 4 times 5 is 20. Now I know I can simplify that fraction, but I'm not going to do that at the moment. And in fact, in exam questions, the examiner will make it clear if you need to simplify a fraction. So if you're good with finding fractions of fractions, it's a small step to find a percentage of a fraction. Let's think. Let's find 10% of 3/4. Okay? Now again, we're going to think of the of as multiplying, but 10%, let's change it to a fraction. 10%, 1/10. So we can change this to 1/10 multiplied by 3/4, and then we can apply that rule. If we remember our rule for multiplying fractions, multiply across the top. 3 multiply across the bottom, 40. So there we are. That is the key skills we need for our GCSE problems. Now let's have a look. I'm going to show you the problem. When you see it, if you want to pause and have a go at it yourself, do that. Otherwise, sit back and enjoy. Combining ratios. So this is all about taking ratios and making them work together in quite a tricky context. So let's look at this GCSE question. In fact, it starts off with something which is fairly straightforward. Only blue vans and white vans are made in a factory. The ratio of the number of blue vans to the number of white vans is 4:3. So I'm going to highlight the ratio because I want to remember that it's blue vans to white vans. Okay, and it's 4:3. And we want the fraction, write down the fraction of vans that are blue. Going back to how we think of the bar, how we think of a ratio as a fraction, we can see 4 plus 3, there are 7 parts. The ratio, remember to look back, is blue vans to white vans. So our blue vans have 4 of the 7 parts. So the fraction of vans that are blue is 4 out of 7. Okay, fine so far. Now we're going to get to the tricky bit. And so much of this is in the question. And for blue vans, and the key to this is, I've missed a bit off in the wording for the question, it's preceded by the words 4 blue vans. So this is all about blue vans. The ratio of the number of small blue vans to a number of large blue vans. small blue vans to large blue vans is 3 to 5. So this is all about blue vans. I'm going to write this down. This is all about blue vans. Okay. So we've got the ratio. Before we try to jump in at the problem, let's understand the problem. Work out the fraction of the number of vans made in the factory that are blue and large. Do you see that? Blue and large. Now, in terms of fractions, if you look up here, we've already found that 4/7 are blue. We've already worked that out. So we're going to be needing to use that. But we want blue, have a look at the question again, and large. We've got the fraction that are blue. We therefore need the fraction that are large. Okay. Let's go to our ratio. Let's read this again. The ratio of the number of small blue vans to the number of large blue vans is 3 to 5. Okay, that's 8 parts. 5 of them belong to blue. So the fraction of, 5 of them belong to large. There's me misreading the question. The ratio of small blue vans to large blue vans is 5. So 5 of the parts belong to large. So the fraction that are large is 5 out of 8. So we've got 5/8 of the vans are large. 5/8 of the blue vans are large. Now that we've got those two fractions, we're ready to nail the question, because the question asks us to find out the fraction of the number of vans made in factory that are blue and large. Blue and large. So 4/7 are blue. Of those, 5/8 are large. So 5/8 of those blue vans are large. We now multiply those fractions. We remember that of is multiply, and we get 20/56. I can simplify that if I want to. The examiner hasn't asked me to. Okay, that's the first question. The next question is similar but trickier. So, as before, with the knowledge you now have, feel free to pause and have a go at that problem. So let's go. In a company, the ratio of the number of men to women is 3 to 2. So at the moment, this seems to be about men and women. Okay, men to women, 3 to 2. The other information I have though is percentages around age. Have a look. 40% of the men are under the age of 25, 10% of the women are under the age of 25. So we've got someone else coming to this now, the percentage under the age of 25. Now let's see what the question asks us. What percentage, now remember that because this means we have to give our answer as a percentage of all the people in the company are under the age of 25. How are we going to do that? So we want to know all the people that are under 25. We've got information about men, we've got information about women, so we have to use that. Okay, so let's first look at the men. Go back to the ratio. The ratio of men to women is 3 to 2. So there are 5 parts, 3 of them are men. So 3/5 of all the employees are men. Okay, we want to know what percentage are under 25 of all the people. We have this information too. 40% of men are under the age of 25. So we actually need 40% of that 3/5. Tricky? It is. That's a key point to get your head around. We want 40% of the fraction of men, because 40% of that fraction is under 25. Now let's think about the skill we developed earlier. 40% as a fraction. I could write 40 over 100. 4/10 is going to make life a bit easier. So 4/10 multiplied by 3/5 is 12 over 50. 12 over 50. Now that is the fraction of men, of employees that are men under 25. Let's have a look at women then. We're given their part of the ratio is 2, 3 parts to 2, men to women. So women have got 2 parts out of the 5. So their fraction is 2/5. Now, of that proportion of women, we're told also that 10% of them are under the age of 25. Have a look. 10% of the women are under the age of 25. So I need 10% of 2/5. 10% of 2/5. Well, I can write 10% as 1/10, of as times 2/5. It gives me 2 out of 50. There we are. That's the proportion of all employees that are women under the age of 25. Now let's go back to the question. This is clearly a grade 5 because of the subtlety in it. We want the percentage of all people. We know the fraction of all people that are women, that's 2/50. We know the fraction of women under 25. We know the fraction of employees that are men under 25, that's 12/50. Let's combine that, and I've got 12/50 plus 2/50 is 14/50. That is the fraction of all employees that are under the age of 25. And finally, we're asked to give our answer as a percentage. Well, I can convert that fraction to 28 over 100, which I can see is 28%. And that is a grade 5 question. Now, that takes us to the end of the series on ratio. If I get any feedback asking me to add another lesson to pick up more problem solving with ratio, I will look at doing that. But for now, that's the end of the series. I hope you find it helpful, and please look for what else is on offer. I love maths, and I really believe I can help you achieve. Help me share this message by just pressing the like button down below, and if you have time and can leave a comment, that would be great. Thank you.